Alright, now we're in section 8.2 and we're going to look at solving a 3 by 3 system using a matrix. So what we're going to do first is set up what's called an augmented matrix. So in your matrix, your first column of numbers will be the coefficients of your x terms. So I have 1, 3, 1. Those are my x coefficients. The next column will be the y coefficients. So 4, -1, 1. The third column is the z coefficients, so -3, 3, and 6. Then we draw a line that represents the equal sign, and then we have our constant terms that are on the other side. So this is called an augmented matrix, and what we're going to do is called row operations, and I wrote up here what our goal is. Our goal is to get it into what's called reduced row echelon form, and that is when you have a 1 in the diagonal, and then you have zeros everywhere else. The reason this is our goal is if you look at this first row is telling us the value of x. The second row is telling us the value of y, and so on. So that is why that's our goal. It's our way of solving for x, y, and z. So the row operations that we're allowed to do is we're allowed to interchange rows, we're allowed to multiply rows by a constant, and we're allowed to add rows together. And for this setup here, we're kind of fortunate that we already have a 1 right here. So what I'm going to do is I'm going to use that 1 to take out this 3 and this 1 and make those into zeros. So for my first step, I'm going to leave row 1 alone. And what I'm going to do is I'm going to take -3 times row 1 and add it to row 2. And I'm going to replace row 2 with that. And then I'm going to take negative row 1 and add it to row 3. And I'm going to replace row 3 with that. So that is what I'm going to get in my next step. So let's get those first before we fill back in with row 1. So -3 row 1 will be -3 plus 3, which is 0. -12 minus 1, which is -13. 12 plus 9 plus 3 is 12. And then 24 plus 12, 36. So I'm looking over here to fill in my new matrix. So negative row 1 plus row 3, a little bit easier. -1 plus 1 is 0. -4 plus 1 is -3. 3 plus 6 is 9. And then I have 9, -8. 9 again. Okay. Now I'm going to just rewrite row 1. I did not change it. 1, 4, -3, -8. Okay. So looking at this, I've gotten 2 zeros below the 1. That is good. And I've gotten, well, what I'm noticing here is row 3. Row 3 has a -3, a 9, and a 9. What you might want to do is just take row 3 and multiply it by 1/3. This will give me smaller numbers. It'll give me a -1 here, which I can maybe use to my advantage. So let's do that. So for my next row operation, I'm just going to do 1/3. So I'm thinking maybe I'll do -1/3 times row 3. This will give me a 1. Okay, so let's see what that does. For a lot of this, you kind of just have to try stuff and just see if it works. And sometimes you can get it done quickly in a few steps. Sometimes it takes forever. It just depends on the problem. Okay, so -1/3 times row 3, I get 0, 1, -3, -3. So I'm not changing row 1 or row 2, so I'm going to just write those in. So this gives me another 1 to work with. This one here, right here, I'm going to use to take out the 4 and the -13. This will give me some more zeros in that second column, so that'll be great. Because I have zeros over here, it won't mess up anything that I've already done. So let's write out what we're going to do. So I'm going to do -4 row 3 plus row 1 up here. I'm going to do 13 row 3 plus row 2. So this is very much elimination. Just kind of, you can do a lot at once when you're using matrices. Okay, so I'm not changing row 3 at all. So I'm replacing row 1 with -4 row 3 plus our row 1. So let's do that. So -4 plus 0, times 0 is 0 plus 1 is 1. -4 times 1 is -4 plus 4 is 0. -4 times -3 is 12. 12 minus 3 is 9. Okay, and then the last one, we have -4 times -3 is 12. 12 minus 8 is 4. Now I'm replacing row 2 with 13 row 3 plus row 2. 13 times 0 is 0 plus 0 is 0. 13 times 1 is 13 plus -13 is 0. 13 times -3 is -39 plus 12, -27. 13 times -3 is -39 plus 36, -3. And then I did not change row 3, so I'll just copy it down as it was in the previous step. Okay, so row 2 looks pretty interesting. I have 2 zeros, and I have a -27 and a -3. So what I think I'm going to do is I'm going to multiply row 2 by -1/27. And I'm also going to move it down because it looks like I want that one to be in the 3rd row. And then I'll just take this last row and I'll move it up. So let's do that. I'm going to leave row 1 alone. So let's go ahead and write out our matrix. Okay, so I'm going to take -1/27 row 2 and move it down here. And then I'm going to move row 3 up into the row 2 position. And I'm going to leave row 1 alone. Okay, so here I have 0, 1, -3, -3. And then down here I'm going to have 0, 0, 1, and then 3/27, reduce 1/9. And then I'm keeping row 1 the same, 1, 0, 9, 4. So now what's great about row 3 is there's 2 zeros and a 1. I can use that 1 there to take out this -3 and this 9. Because there are zeros here, that won't screw up anything that I've already done. So this is going to be probably my last step. So let's go ahead and write out what we're going to do. So I'm going to take -9 times row 3 and add it to row 1. I'm going to take 3 times row 3 and add it to row 2. And I'm going to leave row 3 alone. Row 3 is actually what we want it to be, so there's no need to change that. Okay, so let's set up the matrix. Alrighty, so we're doing -9 times 0 plus 1, -9 times 0 plus 0, -9 times 1 plus 9, 0. Looks great. -9 times 1/9 is -1. -1 plus 4 is 3. Great. All right, now we're going to doing 3 R3 plus R2. So I'm looking at the previous matrix when I'm doing this. So 3 times 0 plus 0. 3 times 0 plus 1. 3 times 1 plus -3 is 0. 3 times 1/9 is 1/3. Right, 3/9, yeah, 1/3 plus -3. So -9/3, so -8/3. Okay, and then of course we left row 3 alone. 0, 0, 1, 1/9. So here I'm seeing a 1 in the diagonals and zeros everywhere else. This is now in reduced row echelon form, and now we can just translate it back to equations to get the solutions. So from this first row we get x equals 3. From the second row we get y equals -8/3. And from the third row we get z equals 1/9. And if you want to, you can write it as a Pythagorean triple. Instead of an ordered pair, there's now 3 solutions.